So our topic is advanced clustering. We covered some clustering topics last month, and those were um, all clustering, but not necessarily related to what we're covering today. Those are the things that are more directly visible in the interface or kind of core things that you always have to do. The things that we're talking about today are things that you could potentially get by with never using, even if you're in a clustered environment. But I think most cluster customers would have benefit in using some of the features we're talking about today, depending on what their environment looks like. So I'll talk about those and I'll try to point out where they might be useful and how they might be useful if you're not using these features already. So from an agenda perspective, I'm going to start with a look at the cluster architecture. I think this is a slide that I used last time. I just want to focus us in on the areas that we are discussing today, so it's kind of clear where in the big picture we fit. And then we'll talk about what does job ownership mean, because it kind of comes into play for all of the settings we're talking about today in some form or other, although we don't always use that language, but we'll talk about what it means to be a job owner and how we change who the job owner is. The next piece we'll talk about underlies most of the rest of it, and that's the heartbeat setting. And then we'll talk about cluster remote execution policies. And this is the piece that's probably going to be most of what we cover today because it's the one that has the most options and honestly is an area where it can be confusing. So I'm going to try and clarify as many of the pieces as I can, lay them out so you understand where you have options versus things that you need to layer together. As a subset of remote execution policy, we'll talk about load policy. You might only be interested in load policy of all the things we're covering today, but it is part of remote execution. If you don't understand remote execution, it's a little hard to do a load policy that's going to do what you want. The last main topic we'll talk about is auto takeover, which is, related but different. And lastly, I'm going to talk about, do you really need these settings? The short answer, if you want to just be done now, is no, you don't have to have these settings. Many of our cluster customers, as I said, don't use them. But I think you'll probably find that there are reasons to, and we'll talk a little bit about those. So this is the basic architecture that I described and looked at last time. The piece that we're really talking about today is essentially all in the blue box in the middle. I've kept the interfaces and the load balancer, which you might or might not have, in the picture because they do have to do with this, but most everything we're talking about here is about the instances in our example, instance 1, instance 2, and instance 3. Those are Rundeck servers. We're looking at these Rundeck servers down here and how we can control which of them will do which jobs, particularly in cases where something might fail or those sorts of scenarios. So that's in a big nutshell the piece that we're. So the first thing I'm going to talk about is job ownership. And there's two types of job ownership for our purposes of discussion. The first is scheduled jobs. So it's important to realize how scheduled jobs are handled and who handles them in terms of which server is different than a job you run on a one-off basis. So for a scheduled job, there's always a single cluster member, a single server that will own a job. That job owner, by default, is the cluster member where the schedule was first created. So if I was logged into server 1 when I first set a schedule for job A, the schedule for job A is going to continue to happen on server 1. I can change that behavior by logging into the cluster manager interface in the UI, and I'll show you that in a minute. But as a general rule, just bear in mind that whatever server you are on at the time you set the server is the job owner. And there's not necessarily anything wrong with that. Anytime the job runs again later, that schedule, not a one-off job, but a scheduled run, it's always going to live on that server. But depending on the way your environment is set up, that might or might not be what you want. You might want to have a particular server in your cluster that handles all scheduled jobs. And so you could manually move those jobs, and then we can talk about what happens when we need to override it on a special basis. The second is ownership of one-off jobs, a job that's run at a point in time. Again, that's going to have a single server instance that owns that job while it's running. By default, the job owner, the server, is going to be the instance the user was connected to when the job run was initiated. So if I log in today and I happen to be on server 1 and I'm running job A, that's going to happen on server 1 if nothing else has been configured to make it happen otherwise. So if you think about a normal load balance configuration, and I mean you've put a load balancer in front of your cluster servers, then you're usually being moved from server to server depending on when you log in. So I log in now and I'm on server 1. I log in after lunch, I'm on server 2. I log in late in the afternoon and I'm on server 3. And that's okay. And that's actually good in this context because it means the load is being spread out. If your load balancer is doing a good job of distributing which server your users connect to, that's also effectively going to load balance the work of running the jobs if you have the default behavior. So the default behavior is not that bad, but we'll talk about remote execution policies as a way of changing that behavior, and there's lots of configuration options if you're going to do that. So heartbeat is a setting that's used with all Rundeck servers and that measures whether or not another server is still alive and able to execute jobs. So we call it heartbeat, but if you wanted to think about it in more human terms, it's like you're poking the person next to you and seeing if they respond. A heartbeat is just validating, is that person still alive so I could count on them to do something. In this case, is the server still alive so it could run whatever jobs it's supposed to. And heartbeat is used in different other systems, which is much of what we're talking about today, but that's what the heartbeat does at its base. There are effectively 5 settings for heartbeat configuration. The interval, how often are we checking? The delay after startup to send a heartbeat. So if a server restarts, when's it, how quickly is it going to try and indicate that it's alive? Some processing messages. How long should you wait to consider a server inactive, which isn't dead, but is the initial point of concern, and then how long for it to be missing before you'd consider it dead. So those are the general settings. You don't actually have to have any of these settings configured anywhere necessarily, but those are the settings you have if you want to change them. The values shown here, I believe in all cases, are the defaults. So if you hadn't set the settings, you can presume that these settings are set as you see here. Okay, so the big piece we're going to try and talk about today is cluster remote execution policy. Essentially, depending on how you configure the policies, a cluster member can send jobs to other cluster members to do the work. So if you remember, the default says when when someone clicks run now on a job, that job's going to run on whatever server they happen to be on. With remote execution, you're going to say, if someone clicks run now, we're going to check a policy, and depending on that policy, decide which server should get that job and run that job. And often that means the job's not going to run on the machine I happen to be on. Where and how it's going to run is dependent on a lot of things in your environment, but this is what gives you that control. But remember, this is control of one-off jobs, not scheduled jobs. So there's a default policy, which is just run every job locally. If there are policies can be defined for all jobs that get run from that server, triggered from that server, if you will, or they can be done based on projects. So I might have several policies where one policy says, if this job belongs to project A or B or C, then send it over here. And if it doesn't have any of those, then it might go to my default policy. So I can have a lot of different kind of configurations here. If you have a lot of teams involved, if there's different geographies, if there's different underlying dependencies, then those might lead you to additional profiles. You might be interested in having profiles if there are some servers that have something unique about them that's important when you run a job. So if you have a cluster and one of your cluster members is an Ansible server as well, but not all of them, then you'd want to make sure anything that runs that's in one of my Ansible projects goes to that Ansible server. And other things could run on any server, including the Ansible server. So there's a lot of different reasons and complexities you can apply. The policies themselves are defined in Rundeck config properties. So one of the complications here, I think, is all of these policies we're talking about today, or methods of configuration, are defined on each individual server. Much of the time, you're going to have the same configuration on all your servers, but the system is built in such a way that you could have different configurations on different servers for various reasons, and that's okay, but you need to keep track of all of that. So we'll talk about what the policy options. So the first configuration option is simply called policy. The policy setting indicates what method of assignment is going to be used for jobs for this policy. So your policy could be none, but then you just wouldn't have a policy. But none says execute locally. And maybe you do want to have that on certain servers, you want it just to execute locally. Random says execute randomly, just pick one from whatever set I have available among the allowed members. And we'll talk about how to define allowed members in a minute. Round robin is the same, except it's going to make sure that we do it theoretically in an even fashion. Go to server A first, then B, then C, then D. Once we've gone through, we'll start back on A and keep going through. It's probably what your load balancer is doing in some cases, but that's what round robin does, and I think it's one of the more common options you'll see. Preset is an option you can use, but remember that preset says you're only going to execute on a particular preset member. So it's basically saying for this policy, there is one place I'm going to send my jobs. And if I remember rightly, I think preset is something you can't use with tags. We'll talk about tags in a minute, but as a distinguishing factor, you can determine allowed members for most of these policies using tags or static references. Preset requires a static reference. So typically preset says, I want to execute on a specific server by naming its UUID. Load is the last and maybe most interesting to many of you, which says execute on one of the servers, but pick which server based on load. Which one is least loaded? That's where I'd like it to go. That we'll be talking about some detail on that toward the end here. But this is all part of remote execution. So if you're going to use a load policy, start by understanding have to have a policy type of load. You'll set some other options to determine who you could include, and then you'll get to the load specific. So next is member tags. Tags are used to restrict which servers in a cluster could be given a specific execution, remote execution for this policy. Tags aren't the only way to define it, but tags are pretty flexible. We're all used to using flags and tags in various ways. And I think this option may be used more commonly than some of the static options we'll talk about in a minute. Tags are something you're also going to define on each server, and you're going to do that in the framework.properties file. So most of the settings we're looking at are in Rundeck config properties for all of this configuration stuff, but the tags are going to be in framework properties. And I'll show you an example of that in a little bit. There's two types of tags for members. Allowed tags are any machines that could have a job assigned to them. And then there's preferred tags. Preferred tags are the ones that you would like to give the job to if they're available. Remember that preferred needs to be a subset of allowed. So whatever tags you're going to use in preferred should also show up in allowed, but allowed might have some additional tag that reflect some different options. What'll happen is when we try to execute, we're going to look for any machines that have that tag in both preferred and allowed, and that's the set that we're going to pick from. If there is no one in preferred and allowed, then we'll look at anybody left in allowed that we hadn't already accounted for. So the general idea is there are certain machines I want to be my worker machines, and I want to send my jobs to those worker machines under normal circumstances. But if they're unreachable or they've gone down, obviously I want them to execute somewhere. So I want to take advantage of whatever machines are available from my allowed set. Worth distinguishing, and I think this is clear, but all the tagging and all the machine naming and all the details we're talking about today are about Rundeck servers, not remote nodes. So we obviously use tags for other things. These are tags that are specific to servers and are defined, as I said, in framework.properties, as opposed to the tags you might have given them in the UI as nodes. So that can be confusing. Okay, the next method of configuration for allowing servers to be job owners effectively is just called allowed. And I referred to it earlier. This is static configuration. You're not using tags, which tags can be dynamic. The options you have if you're doing allowed are self, which says, I'm the one that's going to do my job. Okay. Other, anybody else except me. So if I have one or two servers at the front end that are only supposed to be front end servers, they might all have something that says allowed equals other. So they'll take the UI interaction from the user, but when a job actually needs to run, they'll go ahead and send those requests out to one or another of the servers that are out there. I can also specify a particular UUID or a regular expression that might match one or more UUIDs. Those are effectively the options that I have if I go with allowed as opposed to allowed tags or preferred tags for that matter. The other configuration that I have here doesn't require a lot of explanation, but it's active only, and it's either true or false. This is effectively saying, do you want to use heartbeat as a filter and limit the set of possible allowed members or allowed tags based on whether those members are active or not? Are they considered alive, or are they at risk that they might be offline? So I think, to me, it makes sense that you'd put on the active only configuration, essentially in all cases, regardless of what else you're doing. This isn't specific to allowed members. It could be used with allowed tags, preferred tags as well. Next up, we have profile name. Profile name is really only needed if you're going to have more than one profile. So if you don't do any remote configuration stuff in your Rundeck config, you have the default profile. If you put in just a single set of settings, you're updating the default profile, but there's still only one profile. But if you wanted, as I described in my earlier example, to have jobs in your Ansible projects go to your Ansible Rundeck server, that would be one profile. And if you wanted to make sure that remaining jobs were distributed between all of your servers, then that would be a second profile. If that's the case, you need to have a profile line that defines the name of the profiles or names of the profiles. And you'll notice if you look at the second line here, the config name has profile 1 in the name, or it could be profile 2. That is the name that you've defined, and all the settings have the profile name in them to make sure that you're clear on the distinction between one profile and the next. So profile names is certainly optional, but for any complex environment, I think it's a likelihood that you might at least consider having multiple profiles. The second option here is project name. A project name, again, probably only comes into play if you have multiple profiles, and each of the profiles could have one or more projects associated with it. Your default profile probably doesn't. It's intended to catch the cases where your secondary profile didn't kick in. So in the example on screen, we've said for profile 1, we want jobs from project A and project B. So anytime a job is initiated on this server for project A or project B, then we're going to look at the profile 1 settings to see what to do with it. So if project A and project B were my Ansible projects, to follow the example that I've been using, I think that would make some sense. Could also use this as a way of distinguishing between Linux and Windows projects if you had a mixed cluster environment or something else specific where you wanted to know exactly which server it was running from. Using projects in this way would allow you to do that. Okay, so load balance policy. As I mentioned earlier, load balance policy is a subset of remote execution. It's one of the types. So if you set your policy type to load, then jobs are going to be assigned to individual remote servers based on statistics that are calculated in the heartbeat process. There are two criteria you can use. You can use both of them or one of them. Those criteria are thread ratio and percentage of CPU on that particular member. So the heartbeat process is already gathering that data, and you're then telling it which of those criteria to use. If you're using both criteria, the second option here specifies what weight do you want to associate with each of the criteria. So in this case, we want the percentage of CPU, which is the second option, to be more heavily weighted than thread ratio. So we've said a value of 1 for anything in thread ratio, a 1.5 in load, and so that's going to change how we weight things. So far, so good. The last piece is, how do we establish how many groups we want and how we're going to weigh them? So at this point, the cluster members are going to be sorted by weighted load from least weighted to most weighted, or vice versa, depending on how you will look at it. And of those servers, we're going to cut them into groups. You get to determine how many groups that's going to be. In the example, we have said there's going to be 4 because we have 3 options after the equals, or I'm sorry, 3 commas separating them. And in this case, and as part of that, you're specifying the proportional weight of the group. So it's implied here, regardless of how many groups, that the first group is the least weighted. So at the time I compute, I'm going to split the machines into 4 groups. Let's say we have 8 machines. I've got 2 in each group. The way this is written, we've said we want to always pick from that first group the least weighted group. So it's going to randomly grab one of the 2 machines that's in that least weighted group, and that's who's going to get the job. But I could decide that I've got enough machines or enough variance here that I want to make that a little bit less specific. Even a machine that is partially loaded might be able to take some work. So I could break that down by splitting that 1 across these. But in general, you're going to probably have the first group more heavily weighted than the others, depending on circumstances. So that's the load balance policy. This is still looking at the allowed members you've specified by your other pieces of the policy configuration. So either based on the tags you've specified or UUIDs or whatever the things are you've chosen, you're still limiting it. So you might have a cluster of 10, and there might only be 8 that show up here based on tags. Consequently, you've got a lot of options here, but don't think about it strictly in terms of the load. There might be other things about those servers, the nature of their role. Are they considered a worker for your purpose? Do they handle the UI? Do they handle scheduled jobs? What other things that they're doing that you might need to account for, and that might change how you want to handle these. Certainly looking at the load hopefully addresses many of those concerns, but you probably know logically there are some things you need to address right up front. There are certain servers you may just want to take out of the mix, at least as preferred machines. You may still want to leave them as allowed machines by tag in case no one else is available. All right. So that's load balance policy. Okay, some examples. And I don't know if these are the most logical examples, but I tried to get some examples so we can see some of these things in play. So the first example says our policy type is random. Our allowed is other, and active only is set to true. So it's effectively saying, as long as there is a peer of mine, as long as there's another cluster member that has a heartbeat, we consider it alive, I'm going to give it to one of those. But if that machine, if all those other machines, however many there are all unavailable, don't have a heartbeat, then I could still do the job myself. So it puts us up in a, well, I guess I can't now that I think about it. The way I've written it, it's only ever going to go to one of those other machines. And if they're not alive, none of them are alive, I guess it's not going to go anywhere. So I could have options that might say, I don't know, there's different ways we could approach this. I might do this with tags to be clearer about it and set my machine as allowed and all the other ones as both allowed and preferred to make this work better for me. So that's one option. Example number 2, we changed the policy to round robin. So it's going to change how we decide amongst the available set. But we've also said our allowed is effectively 2 things. Self, so in this case, the server I'm on could take the job, or any machine whose UUID matches the regular expression that's specified here. So I think what's nice about regular expressions, once you get past the arcane nature of them, is I can have something that expresses all of my known UUIDs, or a subset of them. Or if I wanted to, I can just express one using UUID instead of regular expression. But there's a lot of potential complexity there in a good way if you want to use it. And again, we're saying they need to be active. So if a job needed to go, it's going to be round robins between myself and any other machines that match this criteria, unless the machine in question isn't active, and then it's going to go to whoever's next in the round robin.
So there's a question. Can we set the execution policy to any job, or is it just for scheduled jobs?
Execution policies are anything except scheduled jobs. It's a fair question, and we'll talk. We haven't gotten to the end yet. We'll talk about how to handle scheduled jobs. But remote execution and its complexity is really aimed at how do I handle jobs that are triggered on a run now or one-off basis. A job that's set on a schedule is not affected by remote execution policy at all, as it stands. We'll talk in a minute about how those could be handled, but in general, scheduled jobs are presumed to continue to live on their original job owner unless someone moves them, and then they're going to live on that job owner until someone moves them again, with the exception of some sort of failover mode, which we'll talk about here in a couple minutes. That's a good question. Thank you. All right, let's try 2 more examples. So this example, partly what I wanted to do was point out how to use profiles, multiple profiles. So the first line before the specific examples calls out the fact that in this configuration, I'm going to have 2 profiles, one called profile 1 and one called profile 2. And all of the configuration settings have either profile 1 or profile 2 in the config name. So example 1, aka example 3, aka profile 1, has a round robin policy and has specific projects. So it's only going to be triggered for jobs that are running in either project A or project B. If that is true, we have some allowed tags and we also have allowed. So the tags are going to get handled first. We've said that all tags are allowed and the preferred tags are worker and secondary. So if a job needs to run, we're going to try and run it on a server tagged as either worker or secondary. If that is not possible, we're going to look for any machines that have any other tags. And lastly, we'll go to any other machines that are out there that are not me, whoever me is as a server. So if I'm on server A, this policy wouldn't execute on me unless I happen to be tagged in some way, which we can't tell from this. But it's always going to look at preferred tags first. Preferred tags need to be a subset of allowed tags. So, yeah. But if the tags don't provide a set that works, then we'll look at the other allowed criteria, which in this case says other. And for all of this, we're looking only at machines that are active or believed to be active at the time we run the job. So again, based on heartbeat. Okay, so that's that example. The example 4 or profile 2 is fairly simple. It says I've got a preset, which means, as we said earlier, I'm pointing to a specific machine. And then the preset allowed is based on a specific UUID. So if preset is the policy, there should only be one value for allowed. It could be self or it could be a UUID. I think that'd be the only legal options I could have. Again, as I mentioned way back when, preset doesn't allow me to use tags because preset assumes there will be a set of 1, and with tags, there's no way to know for sure that we're going to get a set of 1. And again, we've specified that UUID needs to be active for us to hand the job to it. All right, so there's some examples. I will, as time allows, go and look at a demo cluster I've got set up that has at least one more example of these, so we'll look at that too. Okay, so now we get to auto takeover policy. This actually goes to the question that was asked a few minutes ago. What happens if we're talking about a scheduled job as opposed to a run now job? Auto takeover policy helps with scheduled jobs. It says if at the time a schedule is about to occur, that job owner doesn't appear to be alive, then let's have another machine take that job on and run that instance of the schedule. So auto takeover is not taking that job for the foreseeable future away from its original owner. It's simply saying, for this instance, someone else has to do the job, and so we'll figure out who that somebody is. This does not affect non-scheduled run now jobs. Instead, we use remote execution policy, which gives you a lot of options as we've been discussing to this point. All right, so let's talk about the options in auto takeover. There are 5 settings. You don't necessarily need to include all of them, depending on what you're doing. Some of them have defaults or optional. You need the first one, which tells the system to use auto takeover. You, I think, need the second, although maybe it defaults to any. The second option says, for which machines in this environment do I want to try to do takeover if needed? Do I want it to be for any that appear to be dead, or only for certain servers, which is called static in this instance? The third option, or the third setting, you don't need to include if you want it to have the default, which is this 60 seconds. The third option is called delay. And effectively, it's a built-in window of time. So let me step back for a second. Think about how this is configured and therefore how it occurs. It's configured on an individual machine. So we're looking at it from the context of that machine. We'll call it machine X. Machine X is there and sees, hey, there's a scheduled job about to happen. And server Y is supposed to run that, but I don't see it. So I'm going to volunteer to take on that job. So effectively, machine X is going to raise its hand and say, I can take that next instance of this schedule and it's going to wait 60 seconds to see if anybody else volunteers who might be considered higher priority to take that job. If it hasn't been told not to, because someone else is going to do it, then it's going to run the job after that 60-second or whatever the delay is. And it's doing that initial instance of that particular instance of that job. It's not taking ownership altogether. The fourth option, sleep, says, hey, I did a takeover for a machine. How long should I wait before I offer to do it again if the machine still seems to be offline or is offline again? And I think the default in it actually might be 180 seconds. This one's got 300, but again, you don't have to have this option in your configuration. It's implied and has a default. So the other important piece, if you decide your policy is static instead of any, then you need the last one, which is what are the UUIDs of the machines that you would be allowed to do a takeover for? There could be several reasons why you want to do static policy instead of any, but I'll offer an example, which is to say I've got a mixed configuration of servers. I've got some Windows servers and some Linux servers, and I have things configured in such a way that jobs to my Windows nodes need to go through one of my Windows servers. If a scheduled job is going to fail, I don't want that job to get picked up by a Linux server because it's going to fail. The way our jobs are configured, those nodes aren't going to work successfully from my Linux node. So if you're in that configuration, and I'm not necessarily saying that's what you want to do, but if that's the configuration you're in, then on each of your Windows servers, let's say you have two Windows servers, each of them would list the UUID of the other, so that if a scheduled job failed, it would go to the other server in question and make sure that it stayed in the Windows family, so to speak. That's auto takeover configuration. I think, remember again that it is scheduled jobs only, does not affect a run now job. All right, so we're through the basic stuff I wanted to get across on screen. I do want to show you a few things in the interface just to help wake everybody up from staring at my exciting slides, but I did want to talk about, do you need these settings? I know I said at the beginning that the simple answer is no, and the truth is you probably don't. But I would argue you should have at least a default auto takeover setting and a simple remote execution policy so that you have some sense of what should happen with your jobs. The auto takeover is important because you want to make sure that your job goes somewhere. You scheduled it for a reason. You don't want it to miss that schedule unless there is no way to do it. And with auto takeover, you can have a pretty simple policy that will make sure that all your scheduled jobs get handled by somebody. You don't necessarily care who it is in terms of which server, but you want a policy that will account for that if a server goes offline. Remote execution policy, I think you want to have something there that defines something other than the default policy. The default policy says run on whatever server you're on. That's good. And I guess that works. So maybe it's less necessary. But if you have a lot of work going on, I think you can use remote execution policy to specify a set of servers that are your worker servers, and that might or might not include the servers that do your scheduled jobs if you have a heavy set of scheduled jobs. So you can do some load balancing, so to speak, without worrying about load as such by specifying the machines that could be involved in those cases. So I think it's worth putting something in play, but you definitely don't need to do any of these things unless you see something in how you want to deploy it where you can take advantage of those features. So I am logged into the UI in a cluster. It happens this cluster is all Linux servers. and only really has 2 servers. But cluster manager is one of the things that I brought up. Let me show you how I got there. Oops, I might need to log in. Let me adjust screen size here. Hopefully that is easier for everybody to see. So, so I got to this by clicking on the gear and cluster manager. If you are admin or something comparable, you'll probably be able to see this. Other users might not. When I get here, it shows me my individual cluster members, and there's lots of information in here, which I'm not going to dig into right now. But you'll notice it tells me how many jobs I have scheduled on each of them. And if I click the jobs tab, I'm going to see the scheduled jobs. When are they going to run? And for our purposes, the important piece is which member are they on? So if I wanted to change that, the place to change it is here. I've selected it, and then change schedule owner will allow me to pick from amongst my servers. I want to pick the other one in this case. And it's updating. So as it says, it'll do it within about 30 seconds. But once I've made the change now, Rundeck 1 is going to be the owner of that scheduled job moving forward, unless myself or another colleague makes a change to that, with auto takeover being the way to handle cases where, for whatever reason, that can't run as designed. All right, so we're back. I've still got my same jobs. I still know when they're going to happen, but here I can see which member owns which, and away we go. So I wanted to point this out because if you haven't done it before, I have to say honestly, it's not in the most intuitive spot that I might look for. Once you know, it's easy to get your way there and change those things around. I think it's worth periodically looking at the balance of your jobs and just making sure it's right for you. Right for you might be all 50 scheduled jobs are all on the same server because that server is only used for scheduled jobs. Or it might be that you want to balance them across a set and want to make sure that there's a roughly equal number across each of them. Either is fine, depending on the nature of your cluster. But if you haven't specifically looked at it, you may have an imbalance relative to what you want. All right, let me share a different screen so we can look at some configurations. And this is where it's really going to be fun for people to try and see. Okay, so, and I'm sorry, let me see if I can increase this a little bit. So at the moment, we're in my top left window. I'm connected to one of the 2 servers that we were just looking at in that cluster. And I am in the Rundeck config properties file. So I've added a few things to this file at the bottom of it, just to keep it all clear. So first is our execution policy. We've said we want to do a round robin policy. We want to do it for allowed tags, worker and Linux, and preferred tags, worker. Oops, and I didn't properly fix this, so let me fix my active only line. Okay, so if I look at this, when a job comes along, regardless of what project, that's a run now job, it's going to try to run it on a machine that is a worker machine by preference, has the worker tag, and if no worker tagged machine is available, send it to any machine that has the Linux tag. And we want it to be active. If I come over here, this is the framework file. And the framework file is where we put in the tags. That's really the only thing that's relevant for today's discussion. We've given it tags, worker, and Linux. So it's going to fall in the preferred list, but also could be treated as an allowed with the Linux one. If I look at the framework properties down here, which is the other server, it also has two tags. One of them is Linux and one of them is GUI. So by design in this current profile, it's not going to be the machine to execute any run now jobs because, oh no, I'm sorry, it could be in the allowed but not preferred. So by preference, jobs would go to the top server, and secondarily could fall back to the bottom server because they both again have the same setting.